Hi, welcome to Nomis Academy. In this video, we are going to be looking at tangent theorem, and then we are going to consider theorem 1. In the previous videos, we've considered cycle theorems, and then we also state the theorems, and then we also proved the theorem. But in this video, we are going to look at tangent theorem. First and foremost, what is tangent? A tangent to a cycle is a straight line that passes through one point on the circumference of the cycle. But there are some certain theorems that guide us to solve mathematical problem under cycle theorem. So let's state theorem 1 and then we go ahead to prove the theorem. Theorem 1 says that the straight line which is perpendicular to the radius of a cycle is the tangent of the cycle So the theory says that the straight line which is perpendicular to the radius of a cycle is the tangent of the cycle. So now let's take the diagram to understand what the theorem is talking about. We have a cycle, okay, center at O, and then we have the radius of a cycle at this point. So we call here point P. And then at point P, we have a tangent that passes through the point P. A tangent AB. Okay, so AB is a straight line that passes through the point P, and OP is the radius of the cycle. So in this theorem, we are going to show that of a truth, the straight line AB is the tangent to the cycle. Remember, the tangent of a cycle passes through just one point on the circumference of the cycle. Alright, so let's start with the proof. We are given the cycle centered at O with radius OP and tangent AB. So we are given a cycle centered at O with radius OP and a tangent AB. Okay, we are to prove that AB is the tangent to the cycle. We have to prove that AB is the tangent to this cycle. Construction. Okay. Now we are going to pick at random. We are going to pick any points on line AB. Pick any points. Pick any points on AB. Call the points Q, and then join OQ. So let's pick these points. Let's just pick a point here and call it Q. Okay, and then we are going to join OQ. So we take this point. Okay, so you remember this line is perpendicular according to our theorem, a line which is perpendicular to the radius of a cycle is said to be the tangent of a cycle. Alright, so let's continue with the proof. Now, in triangle OPQ, angle P, that's OPQ is 90 degrees. Angle OPQ is 90 degrees. So it means that angle OPQ is greater than, mind this is not less than, this is angle OPQ. Okay, let me use this symbol. Angle OPQ is greater than OQR. And also the side OQ is greater than the side OP. OQ is greater than the side OP. Now you can see that Q lies outside the cycle, right? Q lies outside the cycle. Therefore, we can say that since Q is any point on line AB, then every point on AB except point P, every point on AB except point P lies outside the cycle. So we can now conclude that OP is perpendicular to AB, and that is why we call this line AB to be the tangent of the cycle. Because any other line you draw, let me show you, when you have this or this, no matter how close it is, no matter how close the line is to OP, in as much as the point lies outside the cycle, that line cannot be said to be the tangent of the cycle unless the line meets at P, which is the only point through which the tangent AB passes. So we can now see that AB is actually the tangent of the cycle. Thank you for watching. See you next time. Bye.